Analysis of a structure, the method of joints. The first step again is to draw the free body diagram of the entire structure and find the reactions at each support point. So this is the step number 1. So to find the reaction forces at each of the support points. So here we have a knife edge connection at point A. So if you remove that, so there will be a vertical force AV and a horizontal force AH, and then you remove this rolling contact at B, so there will be only the vertical force. So we have the free body now, all the external forces are shown. So to find the reaction forces, you'll have to take moments at each of these points. So if you take moments with respect to A and sum everything to 0, that will give you the reaction at point B. So here, so for the 800 pounds, that's going to do a counterclockwise moment with respect to A. For the 800 pound, that will do actually a clockwise. So we'll try to rotate clockwise. So that's going to be negative 800 pounds times the distance from A is 6 feet, minus for that 2000 pound will also do a clockwise moment, and that is 12 foot away from A. And then the 400 pound will do a counterclockwise. So it will try to rotate the whole structure counterclockwise. So that will be a positive moment 400 times. And the line of action of that force is only 5 foot away from point A. So we can say 5 foot there, plus the reaction at B will also try to push this upward right here and rotate the entire structure counterclockwise with respect to A. So that will also be a positive moment, and that is 16 foot away from A, and everything summed to 0. So then we'll find the reaction at B. I calculated 1675, and that's a positive reaction. And then if we take moments with respect to B, similarly we can calculate the reaction at A. So the 2000 pounds now will cause, with respect to B, a counterclockwise moment. So that's positive times the distance of the 2000 would be, we can calculate 6 plus 10 minus 12 that way. Then plus the 800 pound will also do a counterclockwise moment, that is 10 foot away from B, minus that also we have this plus 400 pound that will also do a counterclockwise at C. So with respect to B, it will do a counterclockwise, and the distance of that force of 400, line of action of that force is 5 feet from B. And then we have the reaction at A, area vertical component, A at the vertical component. So that will do a clockwise. We'll try to push this structure upward, so make a clockwise motion, and the total 16 foot away from B. So then we can calculate the reaction at A. I found that positive 1125. And the horizontal reaction we can simply do at A, we can do summation of Fx, that will give us the horizontal reaction. So plus AH minus 400, that's the total load at the horizontal direction. So AH will be 400. So this is the step number 1 in analyzing a structure to find the reaction forces. Next step is to we are doing the concept called the method of joints. So where you only look at these joint points. So these are the joints of this structure. So we can look at different points. Let's look at point B only. So if you look at point B, you only look at point B. So there are one force carried by member BD. So this is my point B, and then we got this force, which is C D, and the vertical reaction at B we calculated 1676, and then this angle we can calculate from this triangle. If you look at this triangle, so this is 4 foot, 16 minus 12, so then this angle we can simply do tan inverse 5 by 4. That will give us this angle. I calculated that 51.34 degree. So this is 51.34 degree. Now here, if you do summation of Fy is equal to 0, we can do plus, I think this is 1675, not 1175. So plus 1675 plus BC sine of 51.34 degrees. So that is the y component of the BC force. That's BC sine 51.34 degree. There is nothing for BD because that's at 90 degree and everything summed to 0. So we can calculate BC here. I found negative 2145 pounds. Now here the negative positive is not that important. What we need to find out is whether this member is in compression or tension. The point we are looking at B in this situation, if that force is compressing B, then it's compression. If it's pulling B, then it's tension. Now here negative 2145 pounds, meaning that the force coming towards B instead of going away. So our original direction this way was wrong. So the actual direction was actually pushing, compressing the point B. So this is in compression. Next we can do summation of Fx is equal to 0. So then we can have that so then the BD is negative, also BC cosine 51.34 degree, so that is equal to 0. Now if you calculate, you find BD is equal to plus 1340, and that's positive, meaning that the direction we assume going away towards B was correct. So it's pulling the point B. So now we're looking at point B, it is pulling that point. So then this is in tension. So this BD member of this structure will be in tension. We're going to do this similar at point A. So now we're going to look at point A and find out all the forces related to that. So point A here, so you got this AC force, and then this way. It doesn't really matter which way these forces you assume. The only matter is if you know a force acting in a certain direction. For example, this 1125 pound is upward, then you must assume that upward, otherwise you'll get wrong answer. But the unknowns can be in any direction, doesn't really matter. This angle we can calculate it by that. So this is 5. So then this angle we can calculate CAB. So that is tan inverse 5 by 12. So I found that 22.62 degree. Just a little bit of, if you round it up or down, the result will be almost very significantly different. So try to keep at least a couple of decimal points here. So that's 22.62 degree. Now similarly we can do summation of Fy is equal to 0. So then we got positive 11 to 5, then positive AC cosine 22.62 degree, everything sum to 0. That's, wow, we got this 400 pound. Well, no, it should be actually sine. We're looking at the vertical direction, so the component of AC in this direction, the vertical direction, would be AC sine 22.62 degree. So then everything sum to 0. Then I found AC is equal to minus 2925. Now again, the plus minus is not really that important. What is important here is it in tension or compression? Now the point we are looking at, in this case we are looking at point D. If the force is compressing, sorry, we are looking at point A. So if the force is compressing point A, then it's in compression. Now originally we assumed the direction AC in this way. However, we found negative, so the actual direction of the force is in from C to A. So it's compressing point A, so it will be in compression. Now we can do summation of Fx is equal to 0. That will give us the other force unknown AD. So if you write that, so you're going to be plus 400 to the right directions, then plus AD, then plus AC cosine 22.62 degree. Everything sum to 0. Then you find that AD is equal to positive 2300 pound. Now again, positive negative is not really a big deal here. The question is this member is in tension or compression? Now we're looking at point A. If that force is pulling point A, originally we assume in the direction of from A to D, so looks like it is pulling that point A, so this will be in tension. Next we're going to look at point C. So then we'll have all the forces of this member. We know AC, AD, BD, BC. The only force unknown is CD. So we're going to look at that now. So look at point C. Let me draw that. Point C here. I'm going to draw a little bit in a way that so this is our situation. So that's A, D, that's B. Remember, we are looking at point C only. We're not looking at any of this. However, it's just gonna be easier to see the angles by drawing this way. So the angle A was 22.62. This one I calculated 39.8. Simply what you can do, so that is 5, and then 16 minus, and this is 5, this is 6, so this is 12, so this is going to be 6 foot. So this angle I have calculated is going to be 10 inverse 5 by 6, which is, I found 39.8 degree. 39.8 degree. This angle I calculated as 51.34. We have shown this previously. So here we're looking at point C, we're not looking at A, D, or B. So at point C we have 400 pounds here. Force, we got a vertical force here, 2000 pounds. And we got all these different components. So this one is simply CA. So I can do D, B, like that. So now if we do summation of Fy, Fx, then we can calculate this DC. So if we do Fy, the 2000 pounds is negative, so it's going to be minus 2000 pounds plus AC. sine 22 degrees. So the AC, that's going to be 22 degree as well, 6.2. So the vertical component would be sine 22.62 degree. And then the BC, that force, so there is 51.34 degree. So that's going to be BC sine 51.34 degree plus DC force. So this is our DC, and that this angle is 39 degrees. So the vertical component of that would be sine 39.8 degree. That's what I got. Everything summed to 0. So if I calculate, solve for DC, I found it minus 1250. And again, plus minus is not that important. What is important is we assume this is in this direction from D to C. That's what we direct. That's the direction we assume. That's how we solve this problem. However, it looks like the actual direction was the opposite. It's from C to D. So it is actually pulling that point C that we are looking at. So if it's pulling the point we are looking at, then it's going to be tension. You can verify this calculation by doing Fx is equal to 0. It should be exactly the same as this 1250. So 400 minus 2145 cosine 51.34 degree, then plus 2925 cosine 22.62 degree, then plus DC cosine 39.8 degree, or my stuff goes. So then you can solve for DC. You will find the exact same thing we have found. Again, the plus minus is not that important. Is it pulling that point or compressing that point? In this case, the point we're looking at, C, is pulling that point. Therefore, it is in tension. Now, when you finishing solving all this problem, find all the component of this member, you will have to show the forces in the triangle. So, for example, a C member, you show that it was in compression. So here the force direction would be like this. And then what do you find for a C? Let me go back there. SC member, what do you find for SC here? So you find 2950. Yeah, we have actually here. So here is that SC force. So we found 2925. That was the SC force. It is in compression, and here the direction is shown like this. For example, this BC force, it is also in compression. So here the direction will be in this direction, and also at A, this B point, the direction would be in this way. And I think this force was 2145. So this was 2145. Similarly, you show each of these forces. So DC, for example, was in tension. So it's going to be actually in this direction here, and then basically pulling that point. So it's going to be like this. And also similarly, you can show AD, BD, and so on.